So welcome students. So in this question you are asked to find limit x tends to 0, integration 0 to x square secant square t dt by x sin x. Now, so first if you do the direct substitution, you can see that if x tends to 0, the upper limit also tends to 0. So this integration becomes 0. This integration tends to 0, divided by 0. So you're getting 0 by 0 form. Hence, you can use L'Hospital rule. That is, you can differentiate the numerator and the denominator simultaneously. So this is equal to limit x tends to 0, x tends to 0. So if you differentiate the numerator, so this is a differentiation of integration. So we have to use the Leibniz theorem. So secant square of, in the place of t you put x square, secant square of x square times the differentiation of x square is 2x. And for the constant, you don't need to write anything. Corresponding to the constant, everything will become 0. Divided by x sin x. What is the differentiation of x sin x? X cos x minus x cos x plus sin x. X cos x plus sin x. That is equal to, as x tends to 0, secant square of x square goes to 1. So this is going to 1. So what I do is limit x tends to 0, secant square of x square is 2 is constant, and let me send this x into the denominator. So divided by cos x plus sin x by x, right? If I bring this x into the denominator, correspond to x cos x, x will get cancelled and you get sin x by x. You know that as x tends to 0, sin x by x tends to 1. And this tends to 1, this also tends to 1. That is equal to 2 times 1 by 1 plus 1 is 2. That is equal to 1. So the answer is 1. Thank you.